let's take a look at this. Number 6 says apply dilation to AC with a scale factor of 2 and the center at point O. I straight up didn't tell you how to do this. And it's honestly, I'm glad I didn't. I hope some of you guys really thought about this. So, apply dilation to AC with a scale factor of 2 and a center at point O. You couldn't really have done this if you didn't have a measuring tool. But the way that we kind of start it is we're not really interested in point B. Why aren't we interested in point B at all? Can somebody tell me? Why does point B not really matter to us? Yeah? It's AC, and B is just on this line, right? I could potentially care about an infinite number of points if I care about point B, right? But I don't really, if point B is not there, it doesn't take away any information that I have about that line. Does that make sense? So I'm really only interested in points A and C. So what I'm going to start with is just drawing lines from O to A. And a line from O to C. Now, I don't specifically have a measuring tool on this, but who could tell me, it says a scale factor of 2. What's a way that I could, remember I've got to draw these lines out, right? I got to draw these lines out to dilate it, right? That's the center of dilation. I've got to draw those lines out to dilate it. It's scale factor of 2, so the dilated shape is going to be bigger, right? It's not going to be smaller. It'll be a bigger line. But say that this was 2 inches right here. Or let me make it easier. Let's say it's 3 inches from O to C. What's the instead of C, what's the name of the point on the dilated shape? It's not going to be C, it'll be C prime. Yeah, and any Transformers fans out there, just Optimus Prime, transforms, dilates, right? C prime, okay. If this is 3 inches from O to C, what's the distance going to be from O to C prime if it's a scale factor of 2? What was that?
Twice as big.
Twice as big. So if that's 3 inches, it'll be 6 inches. Okay, so I don't have a measuring device, but that's why I asked you guys to get a protractor, which has a ruler on it, is because potentially you'd be able to measure that's 3 and then say, oh, okay, right here, that's 6. And so the length of that line, you'd say is twice as long, and then there would be your point C prime right there. And then you do the exact same thing from O to A, where you measure that and then make a line exactly twice as long, and that would be where you'd have the location of A prime. Does that make sense to you guys? Is that pretty clear? Yeah? Okay, we can put our computers away, guys. I don't think we really need them out right now. Okay. So the reason why I didn't specifically tell you how to do that is because, as you probably can tell just from going over this right now, the reality is you guys had all the information that you needed to be able to do these questions. Thank you. You didn't need any other information about scale factor or about dilating shapes or about anything like that to do these questions. You've just never specifically seen a question like that before. And so for some of you, this may have been well, I have no idea how to do this. I've never seen a question like this. Well, the reality is a lot of times in life, you've never seen a question or a problem or a challenge like what you are faced with. And you have to come up with creative solutions in order to find an answer or figure out what to do. And so look forward to more and more things like this, where I give you the basics, I give you the simple understanding, but I don't necessarily tell you how to do everything. It's up to you to kind of come up with ways to do it. Okay, so that's the challenge that you guys are going to be faced with more and more this semester. Okay, is this pretty clear of how to do this? Okay, so from that, you should be able to then easily kind of say, all right, well, I could figure out how to do this one. O to x would be a certain length, double it because the scale factor is 2 to get x prime. All right, and the same deal for all of them. The only one that's a little bit different here is number 10. And number 10 we see that it says the center of dilation is at point C. So if you guys remember, if the center of dilation is at point C, is C going to move at all? Like for instance, where is C prime going to be displaced at all from C? If this is my center of dilation, what happens? No. C prime, the center of dilation O and C prime will actually be the exact same place. And so all that's going to happen is you're going to see dilation in the points B and points A. So for instance, if the scale factor is 1.5, it'll be 1.5 times the length. So B prime would be like here, and then A prime would be like here. And then from that point, you'd be able to say, okay, well, there's my, those are my 2 points, and then just connect them to create your full triangle. So this is B prime, and this is A prime. So you see what we're doing here, guys? When we're dilating a shape, when we're dilating a line segment, when we're dilating anything, we're not, we don't just dilate the whole line, we dilate these endpoints. Does that make sense? We dilate the endpoints, and then we can just connect them to get the new shape. And you could see like, oh yeah, this new triangle is about 1.5 times the size of that one. Okay, is that pretty clear to you guys? Okay, I hope so. You guys see why you need a measuring tool, right? That would basically be not impossible, but impossible to get it accurate without a measuring tool. Okay. Okay. These kinds of things, number 12 and 13, like, I want you guys to notice, like number 12 here. It says determine if it's a dilation. Well, how do I determine if it's a dilation? Well, I determine if it's a dilation if the sides are all the same proportion to one another. So for instance, this one goes over from, let's call this point X, Y, and Z here. Then this would be Z prime, this would be Y prime, and this would be X prime. Okay? So from X to Y, I go over 1 and up 2. Well, from X prime to Y prime, I go over 2 and up 4. So I went over 1 and up 2. Here I went over 2 and up 4. What do you guys think the scale factor is? On the original, I went over 1 up 2. On the dilated, I go over 2 up 4 to get from X to Y. What do you think the scale factor is? 2 is doubled. Well, let's see. From Y to Z, I go left 3 and up 1. From Y prime to Z, I go left 1, 2, 3, 4, 5, 6, 7. I go left 7 and up 2. Does anyone notice something wrong there? Oh, never mind. Sorry. I go over 3.5. I go over 3.5. Sorry about that, guys. I go over 1, 2, 3, and then 0.5. And then I go, on this one, I go over 7 and up 2. So is the scale factor consistent? Is the scale factor consistent? Here, I go over 3.5 and up 1. This one, I go over 7 and up 2. You see? Is it consistent? Is it still 2? Yeah. Yeah, my scale factor is still 2. So what we're seeing here is that basically, if I'm looking at them, it's like, okay, these side lengths are proportional to one another. Now, how could I actually get the lengths of these sides? How could I actually get the lengths of these sides? I could use a measuring tool, but I could also use a theorem, Pythagorean theorem. Look, if that triangle here, this is 1, this is 2, and I'm trying to find this length here, right, the distance, How do I do it? I'll call that c. It's 1 squared plus 2 squared equals c squared, right? So c would equal the square root of 5. 1 squared plus 2 squared is 5 squared. So c would equal radical 5, and that's cool. So I could see that that's radical 5, and then I could figure out this side length here, and I could figure it all out. But I honestly don't want to do that. And so I hope everyone's paying attention right now. I hope everyone's paying attention, because what I'm showing you, and this is something that's like, you could just gloss it over, you could just think I'm just showing you something random, or you could glean the value in what I'm showing you. So I could find these side lengths directly, but here's the reality. Do you think I want to do Pythagorean theorem like 6 times? No, I don't. Nice, Miss Rainier. No, she just stepped out. She said she's covering for the teacher. Okay, yep, you're welcome. So, do you think I want to do Pythagorean theorem 6 times? I don't. Do you guys? No. So, if I want to save time, instead of getting the exact length, that's what I'm looking for, right? Is the exact lengths of these sides, or to make sure that they're proportional. I don't want to figure out Pythagorean theorem. I can just look at this. Well, hey, if this one goes over 1 and up 2, and this one goes over 2 and up 4, then the scale factor seems consistent, right? Well, and I should see that things are doubled in another way. Well, hey, this one goes over 3.5 and up 1. This one goes over 7 and up 2. Okay, my scale factor is consistent. You guys see that? So what I'm showing you guys is like a lot of times, like on something like this, your math book would say, do Pythagorean theorem, solve for the side lengths, and notice that they are doubled. And what I'm saying is like, hey, forget about all that. Don't waste your time. Chances are when you guys are out in the real world, you're not going to be like, I'm just going to arbitrarily do the thing that's harder and takes more effort. Like, no, you're going to be like, I'll get the same exact result by doing it easier with less effort, and it'll take less time. That's what you're going to do. That's what your bosses are going to want you to do. That's what your children and your spouses are going to want you to do. That's what you're going to want to do in your own life, right? So why am I showing you this? Why am I pointing this out to you? Is to help you notice that your brain is powerful and you have the capacity of finding solutions to problems where maybe it's not necessarily given to you. Does that make sense? Okay. All right. So that's that. I don't want to go through the rest. I think we're good. Look at the picture of the mountains. It's so beautiful. Anyhow, you guys cool with that? Cool? All right. So now to the fun stuff. Whoa, what's that? I hope nothing random comes up on this website. I looked through it before and it didn't. I'm going to talk to you guys today about optical illusions. Why? Well, remember when I said that a lot of this is about visualization? Yeah, right? Well, in order to better understand the power that God has given you in visualizing, I want to show you some things that maybe might challenge your concepts of what the visual process actually is. So generally speaking, we think of the visual process as there's something out there. You know, if you've done physics or something, or you just kind of know about this stuff, light photons hit something, they bounce off of that thing and hit my eyes, depending upon the wavelength of the electromagnetic signal, that photon light, it's going to tell me what color it is, and that's cool. And then basically, I'm just receiving all these photons, and my brain is putting them together to tell me, okay, that's how far it is away from me, this is how close it is, you know, whatever it may be. You understand? Concepts of bigness and depth and distance are all mental processes. That has nothing to do with actual vision. Vision is just photons being received by your eyes that are just bouncing off of all sorts of things. Does that make sense to you guys? You're not seeing that that's a mile away. Your brain is processing the visual information and you're deciding that it is a mile away. Does that make sense to you guys? Yeah. Okay, and that same thing is true about depth and perspective and all that kind of stuff. So photons are hitting your eyes and your brain, based on what you're receiving, is deciding what things are and how they're moving, how they're shaped, all sorts of stuff. Does that make sense to you guys? Okay, so the visual process is a little bit more complex than maybe you would have originally thought. And so in order to kind of demonstrate that, I've got optical illusions. So all 4 of you guys, Chris, are you ready?
Yeah.
Okay. You want to do it?
Can I look at the optical illusions?
No, it's going to take the rest of class.
Alright, I'll do it.
Okay. Come on.
No, it's pretty easy.
It's like Oh, really?
Yeah, really.
Okay. So all you guys, though, I want you guys to move here because it's just going to be super hard for you to see and really experience from over there. Yeah, that's all right. That's okay. Okay. So I'm gonna just walk you through some of these optical illusions. Are these all like super mathy type of thing? I don't know, not necessarily. I just thought it was cool and I thought it was valuable. So let's just take a look. Stare at the center of this dot and then move your head closer and farther away and then observe what happens. Can you guys see it? Can you guys see it?
I think you have to move a significant distance.
No, not up and down. It works.
Okay. No, get closer. Here, everyone get up and walk closer while staring at
If
the
you like
black dot.
tilt your head to it and
Yeah, hold on.
Yo, look at spin.
Oh, I see it, I see it.
You see it? It's like
Yeah.
I mean, if you could really just do
yeah, that's cool. You don't have to be like this.
Wow.
Okay, cool, right?
Yeah.
So why is that happening? I don't know, but it is. All right. Okay, this is a cool one. This is a classic. You don't have to go anywhere with this one. I don't know. You guys see it? Yeah, there's just like, it looks like there's kind of shaded areas in those corner points, in those intersections, right?
But there's not.
But there's not. There's not. There's not. There's nothing there. There's nothing there. There's nothing shaded there. That's all just white. It's perfectly white. If I zoom in,
The dark circles in between each line.
My retina is ready.
I honestly don't see them.
yeah.
Yeah,
Well, then-
Okay, so maybe you don't see it, maybe you do. This one's a cool one. It's really hard sometimes for this one. If you just stare at this one, then the colors will actually start to disappear.
This is like a picture taken on Chrome. Oh.
Wait, stop. That's so weird. Oh my god, that is weird. Oh my god.
Wait, what happens?
The colors start to fade when you stare at it.
What?
How does that even?
Yeah,
that's weird.
it has to do with the fact that when your mind is focused on something else, that everything else kind of starts to disappear. This is a really cool one psychologically too. It's
I
like,
don't like that.
if you just focus on one thing, everything else starts to disappear. So think about that in terms of God and how focusing on God, all your kind of challenges in life can start to disappear. All right, this is a very simple one. I think it's easy to observe. Do you guys see a triangle? Yeah, there's no triangle there. It just looks like there is. Okay, that's cool. It's kind of seeing something where nothing is present. There's no there's this shape, but there's no black triangle. That's just being seen. This is a classic one. This is that one you guys have probably seen before. This is one of the impossible shapes. If you look at this, it looks like it's got 3 pegs, and your mind will just process it immediately as having 3 pegs. But if you look closer at it, that's not even possible. That's just an optical illusion. It makes you think that exists, but that's an impossible shape. That's an impossible object. That object could not physically exist, but your mind can process it as a 3-dimensional object. You see? You see this right here? And you can't grasp it, you see? Your mind can't understand it. Your mind wants to turn this into a 3-dimensional shape, but if you follow it along, it doesn't, and then you're like, wait, and then you look here and you're like, oh, you see? It doesn't work, okay? So it's an impossible object. But if you just stare at it, this one's a cool one. The monster illusion.
Oh no.
Yeah, which monster is bigger? You're both nice. This one clearly looks bigger. Why? Well, it's because your mind fills in the details of distance. Because of the way this picture is drawn, this one looks farther away, so it looks like it's bigger. But I've actually gone ahead and taken the liberty of doing something cool. And if you notice, look, bam, they're actually the exact. No, it's just the outline. It's just the outline. It's the exact same shape. So pretty cool. This one, which one is bigger, A or B? Definitely B, right? A or B, which is bigger?
They're the same.
They're the same. They're the exact same. It looks like B is definitely bigger, but the reality is B is exactly the same as A. The way that this illusion is accomplished is because the shorter edge of A is directly adjacent to the longer edge of B. So it makes you think that it's actually smaller, but it's not. You see? It's the same exact size. That's pretty cool. This one is great. Okay? You might just be like, whoa, it's spiral, right? Okay. Okay. So what do you guys think the optical illusion is in this one? What do you think the optical illusion is in this one?
Spiral.
You guys all see a spiral?
Oh, it's hurting me.
You guys see the spiral, right? It's a spiral, right? It's not a spiral.
Yeah, but if you stare at the center,
It's-
like,
It's you say at the center, it's like, whoa, it's crazy, right?
yeah.
There's not a spiral here. This is a series of concentric circles. Those are circles. They're not. There's no spiral there. Look.
Bunch of circles. Yeah.
Whoa.
They're just circles.
That's so weird.
They're just circles. There's no spiral. There's no spirals. It's just look. Even if you just look, you can tell this is just a yellow circle. But in looking at it, it still kind of looks like there's this spiral thing. No, it's just a series of concentric circles, all one on top of another. Pretty cool. This one is good. It's called the Scintillating Grid. This one, if you look at it, you see black dots start to move, right? You guys see that?
Yeah.
Like all of a sudden these black dots are appearing and not appearing. But the cool thing is, if you tilt your head at 45 degree angle, that stops.
Oh.
But if you put your head back,
You squint your eyes.
pretty cool, right? What's going on? I don't know. But it's happening. This one is probably one of my favorites. Okay, blue and green, right? Blue, green, right? Something like that. You guys see that? Okay.
One's blue.
Different colors, right? Very clearly different colors. Okay, bust out the Photoshop, take a look. They're the same exact color.
Wait, I don't understand that.
Look, I'm pulling the color from down here. You see that? That's the color. I'm pulling it up here. What?
Why does it look different though?
Because one is in between. No, our eyes aren't dumb. It's because of the mental processing of the fact that there's the contrast between the orange and the purple. I think that's got something to do with it. But it looks straight up. If you just look at that.
No, like right now.
No.
No, it's
No, it's green. It's the same color. It's the same exact color. But I'm looking at that right now, and it looks like two different colors to me. Right? Does that look like two different colors to you guys?
If you stare at it long enough, it will turn blue.
I guess so. I don't know. Probably.
No, it doesn't turn blue.
Okay. Next one. This is just another cool one. This is an impossible shape. You take a look at it and you're like, okay, that's cool. But if you look at it, it's not actually possible. It's like, okay, you follow it, but how's that back at the bottom, right? So it's just an impossible shape, just to show you. This shows you that your mind can process something as like real, but it's not even possible, right? You could just, oh yeah, I see that. The three-dimensional shape and nature of it at first glance seems possible, but it's actually not. Okay, this is a cool one. So I've taken the liberty here of doing another little Photoshop thing. So go ahead and stare at this for 30 seconds.
Oh, doesn't that look like Jesus?
It does, yeah. So stare at this for 30 seconds. Just stare. You got to stare right at it for 30 seconds. Okay? I'll let you know when to stop. Or I'm not gonna tell you when to stop. I'm gonna flip it to a white screen.
It's getting bigger.
Just stare directly at it for 30 seconds. Stare directly at it. Okay? Keep going. It's okay if you lose focus a little bit. Just keep staring right at the same exact place. Only about 5 more seconds. Just keep going. Hold on. Keep going. Keep staring. Keep staring.
Oh,
Jesus.
You guys see that?
yeah.
Cool.
So,
So- So, and now it's faded, right? Now it's probably faded. Just see a white screen. Usually what you see is like a black face. Where it was white here, you see a black face. So that's pretty cool.
On Instagram.
Understandable. So, okay, this one's pretty cool. It looks like these lines are diagonal, right? Kind of like zigzagging. But these are actually parallel. You see? They're all like horizontal, and these are vertical lines. And it just kind of looks like they're all different angles, but it's just because of the fact that... what's the optical illusion? Sorry. The optical illusion is that it looks like this line and this line aren't parallel. It looks like they're kind of zigzagged a little bit. You kind of see that? But those lines are all actually 100% parallel. So this line here is parallel to that line. They're all parallel. So that's a pretty cool one. This is a classic one called the herring illusion. And it looks like the red lines, right? Are those red lines straight or are they bowed? They're bowed outwards, right? They're bowed, right? They're bowed outwards, right? So that's what it looks like to us. That's what it looks like to us. Bust out the Photoshop and take a look. Look at that. Same lines, completely straight. You see? Just look bowed. Just look bowed because of what the deal is. All right, this next one, Titchener Circles. All right, which orange circle is bigger? The one on the right. But you guys know, right? It's an illusion. They're the same, right? Yeah, they're the same. They're the same, but the one on the right definitely looks bigger to our eyes. Bust out the Photoshop and take a look. Here's the circle. Same exact size. See? So there you go. That's pretty cool. This next one is cool too. If you take a look at these two pictures, well, this one isn't as cool as the other one that I saw. Hold on. They're the same, but look at this, right? If you look at those two pictures,
They're the exact same.
they're the exact same, but do you see that it looks like it's like different angles, right? Yeah, but it's not. It's the exact same angle. Yeah. Those two pictures are the exact same picture. It just looks like the one on the right is more tilted to the right, right? You guys see that? You don't see it? So maybe some of you guys aren't getting tricked. You're super illusion sleuths. Super elite at this point. But you see, it kind of looks like the one on the right is more tilted. But if I just do this real quick. You'll notice that that picture is the exact same. See? Same picture. Pretty cool. It is the 5th, I think. All right. Yes, go right ahead. All right. Next one. Take a look at those squares.
Wow.
Are they supposed to look like they're tilted, but they're not?
No. It's just if you kind of, it depends on how you look at it. Sometimes it seems like they're like rotating.
That means.
Looks like they're shaking back.
Right? There you go. There you go. That's one. Looks like they're kind of rotating back and forth. This is another one that kind of looks like they're moving a little bit. Right?
This one's cool.
No, I don't see that one.
Yeah. This one is great. Stare at the black cross. Obviously, the purple dot's just disappearing, but now stare at the black cross in the center.
Whoa. Wait.
You see that?
No.
It's very green.
You see the green dot?
But even when I don't stare at the
Oh my
black
gosh.
thing. It's still going away.
But no, but it looks like there's a green dot.
No, it's just there.
Is it not?
And then there's like a.
The
Is that
longer
picture
that you
not
stare
moving?
at the black cross, the more it looks like there's just a green dot like spinning around.
Is there not a green dot?
There's no green dot. There's no
I'm
green
seeing
dot.
it all the time. Yeah,
Here,
I'm seeing it.
watch,
in
let me-
my
I'll take a snapshot. Look, I'll take a snapshot real quick.
I'm so confused.
There's no green dot. That was just a snapshot. There's no green dot. It's just an empty space.
But now it's not moving anymore.
Well, that's because I just took a snapshot, just to show you that there's no green dot.
Green dots everywhere.
It's green dots.
Am I supposed to see the thing going around?
You're supposed to see a green dot. Do you see a green dot?
Yeah.
You're gonna see all the dots as you do.
That's the point. There's no green dot.
But I see it without looking at the ground.
Yeah.
It's like moving though. It's like
Yeah.
I don't think this is still a picture. I think this
No, it's not a still picture. It's not a still picture.
But as you look at it, the purple dots disappear, and all you can see is a green dot going around.
Because your brain processes that the dot is still there, but it's not. So it's
Yeah. And it's seeing like it's similar to the black face. Here's the cafe illusion. It looks like they're slanted, right? But all those lines are completely straight. All those lines are completely
Squint your eyes, you can see it.
all those lines are completely straight. So I'll show you. I'll just copy this one.
See?
And you
If you
see-
squint your eyes, you can see that they're straight.
You see? They're all just straight.
No, I get it.
You
yeah,
see?
partially. Because of the squares, the weight of the squares.
They're all just straight lines, you see?
They're straight across.
Slightly.
No, they're straight up and down.
No, that one isn't. Okay, that's it. That's
They're not no. They're clearly like this.
Yeah.
But these lines look like they're
Oh.
like that.
Oh, you're straight.
No, gosh.
Amazing.
It's not that much of an obstacle. This one is the best. If you've tuned me out, then wake up, because this one is the coolest, I think. Look at squares A and B. Raise your hand if you think A is darker than B. Raise your hand if you think B is darker than A.
They're the same.
Okay. All right. Clearly, it looks like it looks like A is darker than B, right?
Wait, what? But there's no real shadow in the picture. I'm
They're
so
the
confused.
same.
They're the exact same shade of gray.
Doesn't make sense.
Look. This is the exact same shade as this.
It's definitely changing.
Right? It almost looks like as I'm dragging it, it's changing color, but it's not. It's the exact same color.
Because of the shadow.
Wait,
It has something to do with what you're expecting. Like, you're expecting that this is going to be lighter because this you expecting to be the same shade as this, but it's actually darker because of the shadow.
I think you skipped a page. Like you said, page
I skipped
4.
page 4. I did. I skipped page 4 because it didn't have any good ones on it. At least I didn't think they were good. So that's pretty crazy, right?
Try and drag B to A.
Yeah, drag me there.
Okay. You want a challenge? Let's see. Challenge him. Okay. So dragging B to A. Hold on.
We all cried.
That is so weird. It like changes it. I'm very why?
Is A the same color as the other black circle?
No, these would probably be darker. Like just like if I grab A, then it's lighter than this one. You see? It's significantly lighter than this. Right? Some psychologists mostly. Mostly like psychologists. Yeah, they probably do. Okay. Killer tofu? Okay. So that was our lesson on
I'm guessing our
Is this another
That was lesson. That was our lesson on optical illusions. And so I guess I wanted to show you this so you guys could just explore visualization, and just seeing what's actually happening, and kind of stimulating your intellects to see what's really going on. So with that, you guys don't have any homework today except for this one task. Your task is this lesson performance task. I'm not going to tell you how to do it. I'm not going to tell you how to begin to do it. I'm just going to give it to you. Okay, so this is 850, page 850. It's lesson 16.2.
We should have a project that's a test grade and we can make our own optical illusions.
That would make that'd probably be pretty hard to do.
Yeah, but it's worth a try.
It'd be worth a try. So what is your actual homework? It's just page 850, the lesson performance task. That's it. What? Yep. Yeah, it's gonna be 5 points just like any other homework.